In this lesson, we are going to be learning about logarithmic functions. We often call these logs. So if 2 to the second power is 4 and 2 to the third power is 8, then 2 to what power is 6? So we know it needs to be somewhere between 2 and 3, but how would we find it? So we use what's called logarithms. That is, how many of one number do we multiply times itself to get another number? A logarithm is the inverse or opposite of exponential. Just like adding is the opposite of subtracting, or just like division will undo or be the inverse of multiplication. So when we are rewriting an exponential function, we can write it as a logarithmic function. And when you read a logarithmic function, you'll read it as log base whatever, in this case base 2, of 8 is x, and you're looking for the exponent for x. So the first thing that we want to be able to do is we want to be able to rewrite logarithmic functions as exponential functions. So to do that, the base is the bottom number, the little tiny number at the bottom, so it'll be 2. The number after the equal sign is the exponent, 2 to the 5th, and the answer is 32 in this case. Next one, 10 to the 0 power equals 1. In the next example, the little 9 is the base, the 1 is the exponent, and the answer is the 9. In the next example, 1/5 is the base. The exponent is a -2, and if you remember, a negative exponent means to flip it over, and then it becomes positive, and then would be to the second power, which is 25. The next set, we're going to rewrite these as logarithms. So this is log base 4 of 16 is equal to 2. In the next example, it's log base 2 of 8 equals 3. In the next example, it's log base 2 of 1/8 is equal to -3. That's writing logs as exponents and exponents as logs. In our next examples, we are going to evaluate or calculate. First thing we're going to do is write this equal to x, and then we're going to rewrite it as exponential. 3 to what power equals 81? We're going to make a factor tree to calculate this because we want to know how many 3's make up 81. When we use our factor tree, we'll break it into 9 times 9, and then 3 times 3 and 3 times 3. So there are 4 3's that make up 81, so our exponent would be a 4. In the next example, we want to set it equal to x, and then we want to rewrite it as 1/4 to what power is equal to 256. First of all, we notice that we would want to flip the 1/4 over so that it would be a whole number, and in order to do that, our exponent needs to be negative. So we should remember that from a previous lesson, that a negative exponent flips it over. So now we're going to make our factor tree for 256. We want to know how many 4's go into 256. So if you take 256 divided by 4, you'll get 64. 64 divided by 4, you'll get 16. And 16 is 4 times 4. In this case, we're not breaking it down into prime numbers to 2's. We want to know how many 4's, and there will be 4 of them. But remember, the negative is important because we wanted to use that to flip it over. In our next example, we're going to set it equal to x, but instead of writing the decimal 0.001, we want to rewrite that as a fraction. And remember, it goes tenths, hundredths, and thousandths. So this is going to be 1/1000. Again, because we want the 10 to flip upside down to become the denominator, we will make our exponent negative. We'll make a factor tree for 1,000, breaking it into tens. And we can see that there's 3 tens in 1,000. So that means our exponent is going to be -3. In our next example, we'll set it equal to x. And we have 64 to the x power is equal to 2. Now this time we are making it smaller. And in order to make a number smaller, we are using a root. A root will make the number smaller. But a root, if you remember, is a fraction exponent. So a fraction will make it smaller. So we're going to use a fraction exponent. So x equals, and it's going to be a fraction. Now we want to know how many 2's there are in 64. We'll break it into 8 times 8, 4 times 2, and 2 times 2. And then we can see that there's 6 2's. So our final answer will be 1/6, remembering that in order to make the number smaller, we're going to take the root of it, which is a fraction exponent. Okay, let's practice a couple more of these. So we're going to set it equal to x. We rewrite it as exponential. We're going to make our factor tree and decide how many 4's there are in 64, and there are 3 4's, so our x is equal to 3. We already did the next problem, so we can cross that one off. In our next example, we're going to write equal to x, so we say 2 to what power equals 1/8. First of all, we know that we're flipping it upside down, so the big number is on the bottom. So we know then that that needs to be negative. So we'll make a factor tree for the 8, and we can see that there are 3 2's. So our exponent will be a -3. We're flipping it upside down, and then there will be 3 2's. Next example, we set it equal to x. Rewrite it as exponential, but we can see that it's becoming smaller. The 32 needs to go down to the 2. In this case, then, we're going to use a root, which is a fraction exponent. And we want to see how many 2's there are in 16. And there are 5 2's. So this is going to be 1/5 as our exponent. Couple of things we need to remember or learn about is that there are some special logarithms. A logarithm of 1, which means any base to the 0 power would be 1. And then the logarithm of base b, which means any base to the first power will be that number, which is that base. On your calculator, we want to look for the 2 buttons that could help us with logarithms. The first one is called the common log, and when you look at that on your calculator, it should say LOG. When a problem is written with a common log, it will not have a base. It really means, though, log base 10 of 7. So what you'll do is press the log, LOG, on your calculator, the number 7, and then the equal sign. and we're going to round it to 4 decimal places, 8451. So this is the LOG on your calculator. Then on your calculator, as we look for the natural log, which has a base of e, on the calculator is ln. So would you find ln on your calculator, and then you'll press 0.25 and equals, and you'll get an answer of negative 1.3863 ln. And you can use these on any scientific calculator. Look for the LOG and the ln. This was our lesson on introductory of logs.